Hello and welcome to Engineers Mindset Academy. So in today's video, we are going to be looking at another topic which have been seen repeated over time in the Jamb examination questions, which is the machines. Now, what is a machine? A machine is simply a device which is used to overcome a large amount of load when a small effort is applied. It is simply a device used to overcome a large amount of load when small effort is applied. Now, there are different kinds of machine which we have in real life. We have wheelbarrow, we have the nutcracker, we have the wedge, we have the inclined plane, we have the plier, we have the screw. You can go on and on to mention different kinds of equipment which have made work look very easy for us. Any equipment or a device which makes work look very easy is simply called a machine. Now, while talking about machine, there are different concepts in machines which we need to acquaint ourselves with. The first concept is what we call the mechanical advantage, and the next concept is called the velocity ratio, and the final concept is called the efficiency of a machine. So let's start with the mechanical advantage. What is the mechanical advantage of a machine? The mechanical advantage of a machine is simply the ratio of the load overcome by a machine to the effort input into the machine. It's simply the ratio of the load overcome by a machine to the effort input into the machine. So mathematically, mechanical advantage signified by M dot A is equal to the load overcome by the machine all over the effort input into the machine. Now, it is important for you to know that the load is simply a resisting force or the force which is overcome by the machine, whereas the effort is simply the force which is input into the machine. So mechanical advantage can also be defined as the force overcome by a machine to the force input into the machine. Or you can simply call that, it can also be defined as simply the output force, because the load is the output force all over the input force. Okay, it can be called as the output force because load is the force overcome by the machine, so it's simply called the output force, whereas the effort is what the force you apply on the machine to overcome what the load, so it's called what the input force. Now, since mechanical advantage is what a ratio of force, it can also be called force ratio. Therefore, mechanical advantage can also be called force ratio, since it is a ratio of force F dot R. So simply output force all over the input force. Okay, all over the input force. Since it's a ratio of force, it can also be called the force ratio. Now let's pick some examples before we move to velocity ratio. Let's pick maybe just one example to explain the concept of mechanical advantage. Now let us say a load of 50 Newton is required to be overcome by an effort of 10 Newtons. What is the mechanical advantage? Simple. Always remember the effort must be less than the load. The effort must be less than the load because it needs a small effort to overcome a large amount of load. That's what makes it a machine. Now let's fall back to the question. A load of 50 Newton is overcome by a force of 10 Newtons. What is the mechanical advantage? Alright, so we're given that load is equal to 50 Newtons and the effort, okay, is also equal to 10 Newtons. Now we are being asked what is the mechanical advantage, or they could also ask you what is the force ratio. Be very careful of that as well. Mechanical advantage is simply what? Load all over effort. So this is equal to load is 50 Newtons and the effort is very small, 10 Newtons. It means that the mechanical advantage is what? 5. Now take note, the mechanical advantage does not have any unit since it is a ratio of force. It doesn't have any unit. It is simply what? Dimensionless. Alright, so that is how you can find your mechanical advantage. Let's say for instance, you're given the mechanical advantage and you're asked to either find the input force or the output force. Let's say for instance, if the mechanical advantage of a machine is 6, what is the effort on the machine when the load overcome is 100 newtons? Now let's do that question and see. Now we are given mechanical advantage M dot A to be 6. We are being asked what is the effort applied. Effort is unknown when it overcomes a load, okay, when it overcomes a load of 100 newtons. All right, so from the formula, mechanical advantage is actually what? Load all over effort. So you need to make what? Effort subject of the formula. We're being asked to find the effort. Now, mechanical advantage can also be written as mechanical advantage all over 1. I've always said when an alphabet or when a number stands on its own, it simply means that alphabet or that number divided by 1. So mechanical advantage simply means MA all over 1. It still remains the same thing. Now, this helps us to easily what? Cross multiply. 1 multiplied by the load and then mechanical advantage multiplied by what? The effort. So I have here 1 times load remains load. 1 times anything remains that same thing. Whereas mechanical advantage times effort remains what? Mechanical advantage times effort. So I have this, okay, but I'm being asked to find what? Effort. So which means I have to divide both sides by what? The coefficient of effort to make effort subject, which means I have to divide both sides by what? Mechanical advantage. Since mechanical advantage is the coefficient of effort in this case. Okay, so divide both sides by mechanical advantage. Now, this simply implies that the effort becomes now load all over mechanical advantage. So this is how to find your effort, the load divided by mechanical advantage. So this is now equal to, the load was given as what? 100 newtons. So you have 100 newtons all over. Mechanical advantage was given as what? 6 divided by 6. So this implies that the effort applied to overcome this load is simply equal to 100 divided by 6. That gives us 16.7 newtons. So the effort applied to overcome the 100 newtons load is simply what? 16.7 newtons. So that's the idea behind what? Mechanical advantage. Now let's talk about the next concept, which is velocity ratio. Now, the velocity ratio is simply the ratio of the distance traveled by the effort arm to the distance traveled by the load arm. It is simply the ratio of the distance traveled by the effort arm to the distance traveled by the load arm. So mathematically, velocity ratio which is V dot R is now equal to distance of effort arm, okay, simply E divided by distance of load arm, which is L. So the distance traveled by the effort arm divided by the distance traveled by the load arm. So that gives us the velocity ratio. So you can simply say V dot R is actually what? E all over L, where E represents distance covered by the effort arm and L represents distance traveled by the load arm. So let's say we are given a problem and we are asked to find the velocity ratio of a machine when the distance traveled by the load arm is 10 meters and distance traveled by the effort arm to be 15 meters. Okay, it's as simple as this. Distance traveled by effort arm E is given as 15 meters and distance traveled by the load arm L is given as 10 meters. So this simply means that what? Velocity ratio is equal to distance traveled by the effort arm E is 15 divided by distance traveled by load arm, which is what? 10. So this simply implies that velocity ratio is equal to 1.5. Okay, so since it's the ratio of distance, also it doesn't have a unit. It remains as what? 1.5. That's how to find your velocity ratio. So depending on how the equation comes, if you're given a velocity ratio and you have to find maybe the distance traveled by the load arm or that traveled by the effort arm, all you need to do is to what? Interchange the equation and then you're good to go. Now, the final concept we're going to be talking about in machines is the efficiency of a machine. The efficiency of a machine simply talks about the capacity or the ability of a machine to overcome a large amount of load when a small effort is applied. Now, how efficient a machine is to overcome such an amount of load with a little amount of effort is simply called efficiency. Now, efficiency can be defined as the ratio of mechanical advantage to the velocity ratio. It can be defined as the ratio of mechanical advantage to the velocity ratio. It is always expressed in percentage. Efficiency is always expressed in percentage. Mathematically, efficiency is equal to the ratio of mechanical advantage to the velocity ratio multiplied by what? 100%. So it is always expressed in 100%. Now, in real life, there is no machine that has up to 100% efficiency. In real life, there is no machine that has up to 100% efficiency. That's the reason why you're multiplying this ratio by what? 100% to let us know that there is no machine that has an efficiency of 100%. But then, on an ideal condition, there are some machines which has what? 100% efficiency on an ideal condition. Okay, such machines are said to what? Not have a friction. Now, why that occurs is that there are machines that are built without friction. If machines has no friction, it means that the total mechanical advantage and the velocity ratio are what? Equal. That also tells that the total effort applied on the machine is used to overcome the total load in the machine. Okay, so which means that for a machine to be 100% efficient, one, it must have its mechanical advantage to be equal to the velocity ratio. Two, it must have the total effort applied on the machine to overcome the total load carried by the machine. And finally, the machine must not have a friction. Okay, so these three conditions are what makes a machine an ideal machine. The first condition, the machine must have its effort completely used to overcome the whole load, which means effort is equal to what? Load. Also, its mechanical advantage must be equal to the velocity ratio. And finally, the machine must not contain any friction. Now, any machine that has these three conditions is simply said to be what? An ideal machine. And its efficiency is simply what? 100%. But in real life, there is no such machine as an ideal machine. That is why we always multiply the ratio, mechanical advantage to velocity ratio by what? 100% to tell us that they can never be up to what? 100%. All right, let's pick an example to explain the concept of efficiency. All right, so let's consider this question to explain the concept of efficiency. Question says a 1000 newtons load traveling at 2 meters is overcome by a 3333.35 newtons load traveling at 8 meters. What is the efficiency of the machine? All right, so considering this question, it says a 1000 newtons load traveling at 2 meters is overcome. So if it is overcome, it makes it automatically the what? Load. Because if you consider the question, it says overcome by a 333.35 newtons load. So they didn't tell us if it's an efficiency, if it's an effort or the load. But a way to differentiate both the load and effort is simply by their what? Value. The load must always be larger than the effort itself. So the effort here is what? The smaller load, which is 333.35 newtons. So which means the larger value force is called what? The load. And therefore the load itself is equal to what? 1000 newtons. And it is traveling at 2 meters. So distance traveled by load arm, distance of load arm is simply equal to, okay, we'll call that L, and that's simply equal to 2 meters. Okay, is overcome by, hence that becomes the effort. Effort is equal to 333.35 newton, which is traveling at distance of effort arm. Okay, the distance of effort arm, which is E, is equal to what? 8 meters, traveling at 8 meters. Now the question says, what is the efficiency? So efficiency is unknown in this case. Now efficiency is unknown, but we know that efficiency is what? Mechanical advantage all over velocity ratio multiplied by 100%. So all we need to do is to what? Find the mechanical advantage, find the velocity ratio, then multiply them by 100. And we know that mechanical advantage itself is what? Load all over effort. So this is equal to, the load was given to us as 1000, sorry, all over, the effort was given to us as 333.35 newton. Now 1000 divided 333.35 newtons gives us 2.95, which is approximately 3. So the mechanical advantage is simply 3. Also, the velocity ratio, we know, is always the ratio of the distance traveled by the effort arm, E, all over distance traveled by the load arm, L. And that's equal to, distance traveled by the effort arm was given as 8 meters. So you have 8 divided by distance traveled by the load arm is given as 2 meters. 8 divided by 2. So this means that the velocity ratio is actually what? 4. Now, if we have velocity ratio to be 4 and mechanical advantage to be 3, then we can now impute into this equation to find the efficiency. And therefore, efficiency is equal to mechanical advantage, which is 3, divided by velocity ratio, which is 4, multiplied by 100%. And the whole of this will give you 75%. So which means this machine is actually 75% efficient. All right, so that is it on efficiency. The next thing I will talk about is the concept of the pulley system. Okay, concept of the pulley system. Then we can dive in straight into reviewing past questions. All right. All right, welcome back. So let's just use this rough sketch to explain the concept of the pulley system. The pulley system is simply a system of pulleys connected by means of a rope or a string to help send down a load by an application of a little effort. So as can be seen, this is the load and this is the effort applied, and these are all the pulleys connected by means of what? This rope or a spring. Now, a little effort is applied with the help of the pulley, and then this load is being dropped either down or taken up, as the case may be. Now, the idea behind pulley is just the pulley itself. The total number of pulley involved gives us the total number of velocity ratio. For instance, in this case, I have 1, 2, 3, 4, 5, 6, 6 number of pulleys. So these cycles actually represent what is called the pulley system. Now, this 6 number of pulleys simply means that our velocity ratio V dot R is equal to what? 6. So if you have up to 5 pulleys, it means your velocity ratio is what? 5. If the pulley is up to 10 pulleys, then it means your velocity ratio remains what? 10. But the number of pulleys, the number of circle here is number of pulleys. It tells us what? That this is actually what? Since this is 1, 2, 3, 4, 5, 6 pulleys, then it means we'll have what? Velocity ratio to be equal to 6. That's the whole idea behind the pulley system. So let's say that the load being sent down is a 120 newtons load, and let's say the effort applied is 40 newtons. Okay, let's say the effort applied is 40 newtons, and let's say the load being set down is 120 newtons load. Then what is the efficiency? It's as simple. Remember that efficiency is equal to mechanical advantage all over velocity ratio. So we need to find mechanical advantage, which is what? Load all over effort. Okay, it is load over effort, and the load is 120. You have 120 newton divided by the effort. Effort is 40. Okay, so this will simply give us what? 3. It means that the mechanical advantage is 3. Now, if mechanical advantage is 3, and we said that since this is total of 6 pulleys, 1, 2, 3, 4, 5, 6, it means that the velocity ratio is what? 6. Therefore, the efficiency is now equal to mechanical advantage over velocity ratio multiplied by 100%. Okay, so mechanical advantage is 3, velocity ratio is what? 6. So multiply by 100%, and this will simply give us 50%. So this machine has an efficiency of what? 50%. So that's the whole idea behind the pulley system. So I'm going to pause the video here, then we can review at least 2 years or 3 years past question in the Jamb examination. So stay tuned till the end of the video. Thanks. All right, so let's consider this particular question. This is Jamb 2022 exam question. It says, what effort will a machine of 70% efficiency apply to overcome a load of 180 newtons if the effort arm is twice as long as the load arm? All right, so let's pick out our parameters. First of all, it says, what effort will a machine of 70% efficiency? So we're given efficiency to be equal to 70%, and I said we always divide this, converting this to in fraction, converting this to decimal points or decimal place by dividing through with 100, it becomes 0.7 as the efficiency. Now apply to overcome a load of 180 newtons. So the load there was given to us, load is given as 180 newtons. We are asked to find the effort effort is actually unknown when if the effort arm is twice as long as the load arm. So you have to be very careful with this condition. It says if the effort arm is twice as long as the load arm, so which means the distance traveled by the effort, which we called A, is equal to 2 times distance traveled by the load, which we call L, which is, this is what the condition is simply saying. The effort arm is twice as long as the load arm. So the distance moved by the effort arm is equal to distance 2 times the distance moved by the load arm. All right, so from here, what you simply do is divide both sides by the load, L. Okay, so this simply means that effort arm divided by load is equal to what? 2. Divide both sides by the load arm, which is L. Now recall that distance traveled by effort arm divided by distance traveled by load arm simply gives us what is called the velocity ratio. So it simply means that velocity ratio, which is V dot R, is equal to what? 2. And that's equal to the effort arm all over the load arm. Hence, the velocity ratio of this machine is simply equal to 2. Now, the question is asking us to find the effort, and you know that efficiency itself is actually what? Mechanical advantage all over velocity ratio. But you also know that in mechanical advantage, we have what? Effort, because mechanical advantage is simply load divided by effort. So what we need to do here is what? Make mechanical advantage is subject to the formula, since we know the efficiency and we also know the velocity ratio. So we simply make mechanical advantage subject to the formula. And if we do that, we are going to find that mechanical advantage is simply equal to efficiency multiplied by the velocity ratio. And this is now equal to, we had efficiency to be equal to what? 0.7. So you put it down, 0.7 multiplied by velocity ratio, you have the value to be equal to 2. So you have this. So this simply implies that the mechanical advantage is now equal to 2 times 0.7, obviously gives you 1.4. So this is now the mechanical advantage. But not forgetting, recall that mechanical advantage itself is actually load all over effort. Okay, mechanical advantage is load all over effort, and the question is asking us what effort is needed. So we have to find what effort, and we're also giving load from the parameters obtained so far. We were given load as 180 newtons, so we can simply make effort subject to a formula that now that we know the value of mechanical advantage. So you simply cross multiply. M dot A also means M dot A divided by 1. So with this, it becomes very easy for us to cross multiply. I have 1 multiplying by the load, mechanical advantage multiplied by the effort. So this simply means that mechanical advantage multiplied by effort is equal to 1 multiplied by load still remains load. 1 times anything remains that same thing, but we have to find effort. So which means we divide both sides by what? The mechanical advantage itself. Now this simply implies that effort is equal to load all over mechanical advantage, and this is equal to, the load was given from the question as 180 newtons, so you put it down, 180 divided by mechanical advantage, we obtained 1.4. So let's obtain what this value is. Therefore effort is equal to 180 divides 1.4. We have approximately 120 newtons. Okay, so we look through the options. Option A says 100 newtons, option B says 90 newtons, option C says 80 newtons, and option D says 120 newtons. So the correct option is actually option D. All right, so we are still going to review another question. Let's review 2023 Jamb question, still on machines. Let's review 2023 Jamb question. Okay, so let's consider this other question. This is Jamb 2023 exam question, still on machines. Question says, the figure below represents a block and tackle pulley system of which an effort W newtons supports a load of 120 newtons. If the efficiency of the machine is 40%, then the value of W is, so we are being asked to find the value of W. W here represents the effort on this block and tackle pulley system. So I said that in the block and tackle pulley system, the number of pulleys tells us the number of velocity ratio on the system. Okay, so it means that if you look through this block and tackle pulley system, we have 1, 2, 3, 4, 5, 6 number of pulleys. So automatically, it means that the velocity ratio is equal to what? 6. So the number of pulley tells us the number of velocity ratio. All right. Also, we were given an effort. Effort was given as W. Effort is simply equal to what? W newtons. And we're asked to find the value of the effort. Now, the effort is supporting a load of 120 newtons. So, which means the load given there is also 120 newtons. Now, in the question, we're given an efficiency of 40%. So, which means efficiency is 40%. Always remember, convert to efficiency by dividing through with 100. It becomes what? 0.4. So the efficiency is 0.4. So just like in the previous example we solved, or in the previous question we solved, it's still the same thing. We have the efficiency and we have the velocity ratio. You recall that efficiency is equal to what? Mechanical advantage all over velocity ratio. So if we know the velocity ratio, we know the efficiency, then we need to make what? Mechanical advantage subject of the formula. So if we do that, we are going to have that mechanical advantage is now equal to what? It becomes velocity ratio multiplied by efficiency. So I have V dot R multiplying by the efficiency. Okay, so having known this now, this simply implies that our mechanical advantage is equal to velocity ratio we obtained is what? 6. So it becomes 6 times efficiency is 0.4, and this will give us about 2.4. Alright, so the mechanical advantage is simply what? 2.4. But then not forgetting that mechanical advantage itself is equal to the load divided by what? Effort. Okay, it's simply load divided by effort. So we simply make load. Okay, we're given the load and we have to find the effort, and effort is W, not forgetting. So which means mechanical advantage, now we have the value. So this simply implies mechanical advantage has a value of what? 2.4, and this is equal to the load was given to us in the question as 120 newtons. So you have 120 newtons divided by the effort. Effort arm was given as what? W newtons. So divide by W. Okay, so from here we simply cross multiply. We have 2.4. This is same as saying 2.4 divided by 1. It still remains 2.4. So this becomes easier for us to cross multiply. 1 multiplies everything here. 2.4 multiplies everything here. So 1 times 120, and then you have 2.4 times W. So 2.4 times W will give us what? 2.4 W, and this is equal to 1 times 120 gives us 120. So we need to make W subject of the formula. To do this, we have to divide both sides of the equation by the coefficient of W, which is 2.4. So this simply implies that the value of W is now 120 divides 2.4, and this is equal to, let's obtain that value. 120 divides 2.4 simply gives us 50 newtons. So it means that the effort applied, or the value of W, is simply 50 newtons. And if we look through the option A says 80 newtons, option B says 50 newtons, which means the correct option is option B, 50 newtons. All right, guys, so that's it on that particular topic, machines in Jamb. It is another important topic for you to watch out for while preparing for your Jamb examination. In the next video, we'll come up with a different topic which we have also seen over time being repeated in the Jamb exam questions. All right, so if you're new to the channel, don't forget to always tap the subscribe button to keep getting updates when the next videos drop. I will see you in the next video. Thanks and cheers.